Hello and welcome to the 31st episode of the Python tutorial series. Today we will discover how to perform numerical integration in Python. But first, make sure to subscribe to the channel so you don't miss any future episodes. If you have any questions about coding in Python or any suggestions about topics you would like to see me cover in future videos, leave a comment below. As you can see from the title of this video today, we will talk about integration. In order to do this, we will be using a Python library called Scipy. Before we do this though, here is a quick explanation about how integration works. When we integrate a function, we are simply calculating the area underneath the curve which the function represents. So, in order to perform the integration correctly, we need three elements: the function itself, the lower bound, and the upper bound of our integration interval. Let's look at an example of how this works. Let's first create a function and call it quadratic of x, a, b, c. And we can say return a times x squared plus b times x plus c. And for those of you who don't recognize this is a standard quadratic function with constants a, b, and c. Now that we have our function, we need to define the values of a, b, and c, as well as the upper and lower bounds of the integration. So we can say a equals 5, b equals 3, and c equals, let's say, 12. Then we can say lower bound equals 0, and upper bound equals 10. Then we can perform our integration by writing result equals quad, where quad is a function taken from the scipy.integrate module. And the arguments of this function will be our quadratic function, our lower bound, our upper bound, as well as a fourth argument which we will call args, and this will be our constants, so a, b, and c. Finally, we can print our result by saying print result. Now we can run our code by pressing the F5 key, and now we have the value of our integration. But wait a second, I'm sure some of you are asking yourselves, why are there two numbers? Aren't we expecting only a single value from our integration? Well, yes, normal integration produces only a single result. But you must remember that in any coding language, we are performing numerical integration, which carries with it a small amount of error. So now that makes sense. The first number is the actual result of the integration, whereas the second number is the error associated with the calculation. As you can see in this case, the second value is actually really small. So that means that the result we have obtained is very reliable. A larger error would have indicated that the integration algorithm implemented by the Scipy library was unable to calculate the result with sufficient accuracy. Having said that, I should also point out that the Scipy library allows you to perform double and triple integrals using the dbl quad and tpl quad functions respectively, whereas ordinary differential equations can be integrated by using the odint function. If you want to explore these functions more, I'll leave a link to the Scipy integration guide in the video description. If you'd like me to cover any of these functions in an upcoming episode, let me know in the comments below. Now let's look at one last type of integration. One where instead of having the function, you only have sample data points. As you can see here, I already have some points along the x-axis, with their respective y values being given by the same quadratic function as before. We can now use the trapezoid function to calculate the value of the integration by writing result equals trapezoid of y comma x. Now remember that here x and y are switched compared to usual, so it's not x comma y, but y comma x. Then we can say print result. Now the trapezoid function calculates the integral by approximating the function as a straight line between each sample point. And as you can see, if we run the code by pressing the F5 key, the result we get is rather close to what we got earlier. Another function you can use to calculate integrals using sample points is called Simpson, which approximates the function by assuming a parabola between each set of 3 sample points, instead of a line between each 2. Having seen an overview of how to integrate in Python using the Scipy library, we have now reached the end of today's episode. Next week we will learn how to use the Scipy library to perform interpolation, so make sure to subscribe to the channel so you don't miss it. If you have any topics you would like me to cover, don't forget to leave a comment below. In the top right-hand corner of your screen and in the video description, you can find a link to the previous Python tutorials and to my coding challenges, so make sure to check those out if you haven't already done so. As always, I look forward to seeing you next week, and until then, happy coding!